semester for our senior project, we worked with Anchor Distributors. This Pittsburgh family-owned business specializes in the distribution of Christian books and other products. They have a 200,000 plus square foot facility with over 30,000 SKUs. They deal with a wide array of order variations. Anchor Distributors are planning to expand their client base and potentially add a second warehouse. However, before they do that, Anchor would like to make sure that their current operation is working efficiently as it can. The problem: Anchor's current policy of offering same-day shipping for orders placed before 4 p.m. costs them to receive the bulk of their orders between 2 to 4 p.m. With their limited capacity, it forced staff to work overtime and rush to meet truck deadlines. Our team has identified that the serpentine picking strategy was one of the root causes of their limited capacity because it caused staff to pick 80 lines per hour and walk 10 to 12 miles per day. The average lines per hour for a distribution center is around 150. The goal. Our goal is to redesign the picking strategy to increase picking capacity, reduce overtime, and reduce the distance traveled per day.
During the project, we made sure to incorporate concepts learned from our past classes in the Industrial Engineering Department here at Pitt. Overall, we used concepts from 9 classes, but the 2 classes that we focused on the most include facility layout and material handling and simulation engineering. In facilities, we learned about various kinds of picking, especially zone picking, and about AGVs and conveyors. We used this prior knowledge in our brainstorming sessions and presented the ideas to our client. We also used many concepts learned in simulation engineering such as Simio, a program used during the class to simulate different processes. While these were the 2 most important classes used in our project, we also used engineering management through important scheduling documentation like Gantt charts, linear responsibility charts, and work breakdown structures. We use engineering product design after using SolidWorks software to design the current layout with proper dimensions collected at the site. Human factors engineering was used through ergonomics. Although ergonomics wasn't our main focus during this project, we made sure to factor in safety of the associates at all times in our redesign. We also used engineering economic analysis with a cost-benefit analysis and productivity analysis with time studies necessary for our simulation. Finally, we used total quality management and Six Sigma during the entire project. Through optimizing efficiency, this can lead to sustainable initiatives and safety optimization. If associates are able to finish their work sooner, anything that might be affecting the environment negatively will be shortened. Having a worker in a potentially unsafe area after a certain amount of time will be reduced if the worker is efficient and quicker in that area. Finally, using concepts we learned during this project will save the company money and increase manufacturability if that's the goal based on consumer need.
Current layout data collection. Prior to proposing changes, we needed to obtain data on the facility layout and the picking process currently in place. For the facility layout, we counted the total number of shelving units and the number of units in each row. Time studies were used to collect data on the picking process, particularly employee walking time and pick time per SKU. Brainstorming new layouts. Based on the data collected, we determined a zone layout would optimize Anchor's picking process. From there, we brainstormed layout ideas by varying the number of total zones, the area and the SKU content within each zone, and the equipment required to move orders through the zone. Testing proposed layout. We then worked with Anchor to beta test our proposed zone layout and collected data on walk time and pick time for each SKU. By comparing the simulation made using this data to the simulation made using data collected from the original layout, we confirmed the improvement of our proposed changes.
Data analysis. We conducted a time study of the workers at Anchor so that we could calculate a walking and picking distribution for the current layout of the model. We observed a variety of staff from petite middle-aged women to tall younger men, and so the data that we collected and found a distribution for, we kept as a constant throughout the rest of our model. From the data of orders from the last quarter of 2016, we were able to analyze it to find an hourly average of lines in the hours of 7 a.m. to 6 p.m., an hourly average of orders received, and an average of lines per order received ratio. Modeling the facility. Using the data collected on the time studies for the picking rate and walking rates, we built in logic to replicate an employee's work in the facility in a given day. We also used the data given from Anchor regarding the lines per hour from the 7 a.m. to 6 p.m. timeline to create logic showing their arrival of lines and orders into the system. In the model, we use the picking rate as a constant, and the analysis of the lines per hour in the 7 a.m. to 6 p.m. times, we use logic to show their arrivals into the Anchor system. We also used the information regarding the picking and walking rates that we calculated from time studies and kept them constant in this and the next model. We also implemented logic to see how many of the orders and lines are not processed given the current deadline of 4 p.m., as well as how many lines would not be processed if we change this deadline to 3 p.m., as well as what would happen if we changed it to 5 p.m. We also modeled the new facility layout that we came up with. Given the data regarding aisle visits for the last quarter of 2016, we used our supply chain measures of the ABC dollar values of these items to create 6 new zones on the floor. These zones were also approved by the management in our live action replication of what would happen. Using this information, we calculated the probability that a line, a single SKU in an order, would occur in each of the zones. We modeled the facility based on the lines once again, and using the data from the lines per hour, we used the same logic for the system arrivals that we used in the first model. We kept the picking rates constant as well, and we built 6 different locations into the model, and as well as logic to have the lines be processed in each one of these zones only once. The same deadline logic was also implemented regarding the 4 p.m. deadline, as well as changing it to 3 or 5 p.m. We also modeled the new facility plan based on orders processing. We took the data received once more from Anchor and analyzed it regarding the amount of orders per hour used in that 7 a.m. to 6 p.m. time span. We took the picking rate from our time studies, and which was originally exponential, and turned it into an Erlang distribution, which would better represent the amount of lines in each order that would be picked from a certain zone. As well, we used the same logic regarding the timelines of 4 p.m., 3 p.m., and 5 p.m. to see how many lines and orders would not be processed in a given day once they were received. From all these models, our results showed us the employee utilization, their percent of time working, and the percent of time not working, as well as the amount of lines and orders that are not processed in the same day that they are received, given the current 4 p.m. deadline, as well as when we changed it in all 3 models to the 3 p.m. and 5 p.m. deadlines.
For the control metrics, we looked at 3 important aspects: quality, productivity, and labor. When looking at the quality and productivity, we looked at the average distance walked between lines as well as the average time to pick each line. We compared this data collection to a live simulation of how it would be perceived to work with technological advancements, such as conveyors. Then the 2 data collections were compared to one another. Another metric that was used included lines per hour completed, which assisted in comparing various zones and looking at improvements with simulation models or zone variations. The last metrics we looked at were costs. For that, we looked at labor costs and overtime costs to see if that would vary based on the total hours worked per day and the number of pickers that worked each day.